Hey everyone, since we finished the law of sines yesterday, today we're tackling the law of cosines. So ready?
Not really. I always mix it up with the Pythagoras theorem.
Actually, that's a good starting point. The law of cosines is kind of like a generalized Pythagorean theorem for any triangle, not just right triangles.
Yeah, that's true. In right triangles, the Pythagorean theorem works because one angle is 90 degrees, but for non-right triangles, we need something more flexible. That's where the law of cosines comes in.
Right. So let's write it down first. The law of cosine states that c squared is equal to a squared plus b squared minus 2ab cosine of c. Where a, b, and c are the sides of the triangle, and c are the angle opposite side.
Exactly. And notice if C is 90 degrees, cos 90 degrees is equal to 0. So the formula becomes just C squared is equal to A squared plus B squared, which is the Pythagorean theorem.
That's so cool. So basically, the law of cosine covers all the types of triangles, not just the right-angled ones.
Correct. Now, when do we use the law of cosines?
We use it when we know two sides and the included angle is a case and 1 to third side. We know that all three sides and want to find an angle.
Right. Law of sines works when you know angles and sides nicely paired. But if you only know sides of or you have an included angle, you need law of cosine.
Okay, enough with that theory. Let's do a simple example. Suppose we have a triangle where A is equal to 5, B is equal to 7, and angle C is equal to 60 degrees. Find side C.
Alright, so step by step, we write down the law of cosine, which is c squared equals to a squared plus b squared minus 2ab cos c. Substitute the value. C squared is equal to 5 squared plus 7 squared minus 2 multiplied by 5 multiplied by 7 cosine multiplied by 600 ay 60 degrees. Simplify. C squared is equal to 25 plus 49 minus 70 multiplied by cosine 60 degrees. We know that cosine 60 degrees is equal to 0.5. So, C squared is equal to 25 plus 49 minus 70 multiplied by 0.5. C squared is equal to 74 minus 35. Then C squared is equal to 39. Thus, C is equal to 39. The square root of 39 is equal to 6.24.
Nice! So side C is about 6.24 units long.
Notice how it is important it is to substitute accurately, especially with the cosine values.
Also, always double check your calculator. Degrees mode, not radians.
Okay. Okay, now what about using the law of cosines to find an angle? If all three sides are known.
Good idea. Let's try it. Suppose A is equal to 6, B is equal to 8, and C is equal to 10. Let's find angle C. First, rearrange the law of cosine to solve for cos C. Starting with C squared is equal to A squared plus B squared minus 2AB multiplied by cos C. Rearranging 2AB cos C is equal to A squared plus B squared is equal to C squared. So, cos C is equal to A squared plus B squared minus C squared over 2AB.
So now, substitute values. Cosine C equals 6 squared plus 8 squared minus 10 squared divide over 2 times 6 times 8. So let's simplify. Cosine C equals 36 plus 64 minus 100 divide 196. So Cosine C equals to 0 over 96. And cosine C equals 0. Thus, C equals cosine 0. Using the calculator, C equals 90 degrees.
That makes sense. A triangle with sides with 6, 8, and 10 is a classic right triangle.
Right. It matches the Pythagorean triple.
So in this case, law of cosines confirmed that triangle was right angled.
Exactly. That shows how law of cosine works for any triangle, but when it's a right angle, you just get a cosine of 0.
Let's summarize the procedure when solving triangle with law of cosine. Step 1. Identify whether you're solving for a side SAS or an angle SSS. Step 2. Use the proper law of cosines formula. Step 3. Carefully substitute knowns and known values. And step 4. Solve for the unknown. And last step 5. Double check mode or degrees and double check your final answer if it is reasonable.
And remember, after finding a side or angle, you can sometimes switch to law of sines to find the rest more easily.
That's a pro tip. Law of cosines for the tough first part, then law of sine to finish quickly.
Let's do a full application problems to wrap up.
Sure, how about this? In triangle XYZ, side X is equal to 12 cm, side Y is equal to 15 cm, and include angle Z is equal to 120 degrees. Find side Z.
Alright, start with the law of cosines. So, Z squared equals X squared plus Y squared minus 2XY cosine Z. So, substitute Z squared equals 12 squared plus 15 squared minus 2 times 12 times 15 cosine 120 degrees. Then simplify Z squared equals 144 plus 225 minus 2 12 15 cosine 120 degrees. First, cosine 120 degrees is negative 0.5 because 120 degrees is in the second quadrant where cosine is negative. Thus, Z squared equals 144 plus 225 minus 2 times 12 times 15 and times negative 0.5. Simplify further. So, first, calculate 2 times 12 times 15 times negative 0.5 times 2 times 12 times 15 equals 360
360 times.
and 360 times negative 0.5 equals 180. Thus, Z squared equals 144 plus 225 minus negative 180 and Z squared equals 144 plus 225 plus 180. Z squared is equal to 549. So finally Z is equal to square root of 549 equals 23.43 cm.
Awesome! So, side Z is approximately 23.43 centimeters.
Notice how the negative cosine turned into adding. That's very important. Mistakes often happen when you miss the negative sign.
Definitely. Also, we can see that when the included angle is obtuse, the third side becomes the longest side.
Good observation. So, for obtuse triangle, law of cosine is super helpful.
So before we end, let's list common mistakes with the law of cosines. So forgetting the negative 2AB cosine C part. Wrong substitution, especially with cosine of obtuse angles. Forgetting parentheses when entering into calculator. Not switching to law of sines when needed to finish solving. and calculator in radians mode.
Parentheses really matters because without them, the calculator will do weird operations.
Quick tip: if the side you find seems impossible, like a negative length or angle over 180 degrees, double check your computation.
Yes.
Great discussion. I feel like now law of cosines is way clearer.
Same here. It's actually logical if you break it down slowly.
Agreed. Let's keep practicing more problems later so we master it.
Whiz, here we come.
Let's conquer triangles, one cosine at a time.
Wala.